so I'll give like a quick demonstration too. I'm not really here, this is what I telling these guys, I'm not really here to demonstrate Cyverse per se. Cyverse is developed by, Discovery Environment is developed by Cyverse. So what I really want to do is put it in context of what we're doing in DFC and what we think it means and what's happening here and going forward that may be of interest. Conceptually, the broad strategy we have here is, and so this is coming from me, so I'm not speaking for everybody, but this dovetails nicely with what Kenton was saying. We're maybe at a layer below, I think, a lot of the things that are being discussed that look really beautiful and we're really interested in interoperating. But we see the data hub as an emergent network of nodes, and so what I mean by that is we're less focused on developing a site as much as we are in developing software that can be used to form constellations of sites, and this can occur in my mind around sort of the centralized nature of data hubs as they exist. And the idea is we want to embed policy management and openness from scratch pace to published reference collections. This is a tip of the hat to Regan's data lifecycle concept, which is we're really interested in what happens below sort of public visibility of data and metadata from where independent researchers are working, doing computation, all the way to where they form collections that can be published. And we want to sort of consider that whole spectrum. The idea is that data can be my data before it's our data, and we want to make sure that we can handle that data in one context from all these transformations that can happen before it's finally visible in something like a published endpoint. Again, just like the internet, we want to sort of see if data grids and cyber infrastructure actually behaves like the internet as we know it. So the idea is local nodes freely associate. We're able to network and federate together with local control, and I'm emphasizing that after the visit to the Northeast Data Hub, where they're really interested in party-to-party data sharing mediated by agreements. So we want to sort of take that sort of idea and apply that to the data hub concept. So maybe the big data hub is the red focus of this chart, but then there is a network that emerges around and can connect to or be independent of that central hub, but using all the same infrastructure and concepts so that one can join the larger collective selectively at points or at will. It has to service the entire data lifecycle, and it has to support discovery by appropriate audiences, and that sort of implies things like the Data One catalog and things like that. Borrowed this shamelessly from Regan. That's his idea, from scratch space to shared reference collections, that you have policies that mediate that. So you may share between two parties working on research and do analyses pipelines. Those products end up in digital libraries and finally into federated sustained collections, which may be something that things like India Share or C or so forth represent on the far right of the spectrum. So to facilitate that, we're working on what is the Apache web server of data. Some basic things that are sort of easy to sort of grok would be it's open source and ubiquitous, and it's packaged for the hardware and software ecosystem of what's out there in research land or where people are doing real work. And then beyond that, what are the facilities that are needed? Policy management, again, to support that life cycle. And as Kenton is indicating, and I think that's a sort of brilliant thing that Kenton just demonstrated, is this confluence of data and computation, which is where Cyverse really, Discovery Environment really sort of represented to us that concept brought to practical fruition. Ubiquitous discovery through metadata indexing and discovery, and also high performance data storage and transfer. That last one cannot be discounted. And so as we think about the data hub, we can talk HTTP all we want, but eventually we are going to have to move big buckets of data around. And so the whole thing has to rest on a substrate that can handle sort of this management of data movement. Okay, so my other foot is in the consortium. So we want to rely on the consortium model for the underlying data. This is where the scratch space, from my scratch space all the way out to these published reference collections, it has to rest on an integration with things like storage technology, as well as high-performance computation. So these are some of the people that we're working with on the consortium side for that. Not on here is Intel, who just joined, and so we're going to be integrating this technology with Lustre. In terms of sustainability, in terms of that scratch base to federated collections, that's what we're interested in. This is a tip to what we saw at the Northeast Big Data Hub, and why it's an emergent network is because you may have an organization A who wants to share some medical data with researchers at organization C. So they want to have data sharing, but under control so that they can enforce policy data sharing agreements. So in this case, it's a fabric because A and C can enforce their data sharing agreement, but also C and B can share, for example, products of that analysis and prove back to organization A that their data has been handled according to the prescribed policies and so forth. So all this is really saying is that within that network, it's not all open, that we have to design and do something that allows these kinds of restrictions and sort of little clusters of this network to work on little islands of policy, if you will. So we looked at DE from Cyverse as a season sort of starting point for the data workbench part of this, which is, tools for data access and sharing and basic metadata management, as well as a model for accessing computation, including their model of bring your own compute, which sounds a lot like what Kenton is talking about. That means that researchers can Dockerize tools, throw them in there, and have their environments be able to execute what researchers provide for analyses on the data that sits inside the environment. And that can also include, as we're talking about, shipping that computation to the data within this environment. Again, controlled with the policy, though, so that, again, if it's medical data or sensitive data, that we know that only certain kinds of computation can happen and how to process results of analyses. So we looked at DE as providing a service layer, too, that we can exploit and adapt for these use cases. Again, in Kenton's presentation, he had a really good overview, I think, of some of the use cases that the data hubs are going to have to follow, and the attractiveness of the Cyverse stack is that it sort of has a functioning embodiment of a lot of those use cases. So kind of a central organizing component for us that would also include other interfaces and access methods. So quickly on status, what we had done over the last few months is take the Cyverse architecture and, with the help of the Cyverse folks, take it out of Cyverse and now start running it as a standalone software package on top of this other data layer I was just mentioning. So we have Visor with the Odom Institute that is using DE and this architecture for social science data, integrated so that you can publish from that environment into Dataverse, and they're using a lot of R analysis tools. So they provision their environment with these tools, and they're doing R there now. Within DSC, the last thing we did was with Bakanam and John Goodall at University of Virginia have taken her hydrology workflows, Dockerized them, and we can run them in this architecture, but also we created a gateway so that things like HydroShare can launch apps using the same infrastructure. So it becomes a generalized service in the same way that we could.
So this is the SciShare thinking.
Yeah, okay. Yeah. And also just recently, this was presented at the BRAIN Initiative by the UNC Neuroscience Center, is we've also created, these are 3 environments we've created. So this third environment is linked to GPU resources, and researchers are doing imaging of mouse brains using GPUs. And so again, we can do this all through the same set of environment and services. And this was just presented by Jason Stein over at Neuro. And that's going towards a pipeline that pushes that all the way to agents that are on microscopes that can take the images and go through a QA process, go through creation of collections, pushing that through analysis and so forth, using these same patterns over and over again. So we're working with Nirav and the Cyverse folks who are putting together an official community DE as a software package. and then we're working with the consortium to extend the pluggability of those services in towards the core architecture over on the IRODS consortium side. So extension points for metadata curation, indexing, discovery. So for example, we just met with Data One to see about formalizing a sort of a plug-in Data One member node software stack, and formation of collections across distributed grids so that you can have collections in multiple places that all appear as one collection, but are still having all the policies enforced at all the various nodes. And standards, commodity approaches for data sharing, and the idea of a la carte installation of components. So this is more about, I'm a shop and I want to do data sharing. I need this piece, I need this piece to run as services on my hardware or out in the cloud, but my own computational infrastructure, like we run Apache Web Server to serve web pages. I don't have a ton of time, and again, I wasn't going to really demonstrate DE so much, but for those of you who have not seen it, the visual model is of a workbench where you have data. So this does all the sort of things you've seen over and over for sharing data, doing metadata management, setting ACLs and things like that, upload, download. It also has a view of apps where people can bring their own pieces of computation. For example, here's Bakanam's hydrology workflow app. It's a Dockerized image that goes in the environment, and then you can stage data to it, run the analysis, run the app, and then the results of the app show up here in the analyses. And you can run stuff both on high throughput environments like Condor, as well as they've integrated this with the Agave Science API, so you can also run apps on high performance computing like down a TAC. So the idea here, I know that's really quick, but I think you guys have already seen Cyverse, but the idea is we've taken that out of Cyverse. It's now an independent software stack. It's being integrated with the data grid, and we're working towards a future where there is this interface as well as a generalized REST service API that can be installed with pieces as needed at an institution, at a business, and that will integrate with their high-performance storage that they're buying from DDN or EMC or okay. So I'm going to stop there. I know that's a whirlwind, and hopefully at least some of that made sense. I feel like I'm going 100 miles an hour. So I'll open it for questions if there's any time remaining at all.
Questions or discussion? You got plenty of time. You're good.
Questions?
Yeah. Are there questions, folks who are listening in on the phone, or discussion points?
Mike, do you have examples of the type of applications that Narad is running in his environment?
Yeah, I wish he was here to characterize that. I know that they do a lot of gene processing pipelines. There's a lot of work with DNA analysis, and I think they do a lot of spatial analysis. It's really open-ended, though. Yeah, I don't have much more to say about the particular kinds of analysis they're doing. I've always seen it more as software that is completely pluggable, again, so that you can do gene processing pipelines like Cyverse does, or you can do our analysis of statistical data if you provision it as such the way that Visor did. So it's almost like the kinds of processing are less relevant. That's another way of saying I don't know.
I have a question.
Yes.
This is Raja.
Hey, Raja.
One question I want to ask you is that since you have integrated DE with IRODS in a sense, and then have this interface on top of the data grid, now IRODS itself is a federated data grid, so you can go to a data which is in any of the underlying zones of IRODS. gives you the zone of zones and things like that. Can you do the same thing for the apps also? Apps can be from multiple zones, and you can look at them and use them across zones and things like that?
Currently, that use case is not supported. That is something that we were talking with Cyberse about adding federation to other aspects of what they do, because they already have use cases for that.
Yeah, we know that the IRODS exports federation for data and metadata, but having it export for app also will be a really good one.
Right, and I think the focus we have right now would be like the definition of what we're calling a computational resource as sort of a packaged installable piece, so that you could have a storage grid, but then you could identify certain nodes as being a sandbox for the computation. So we had a conversation with Kenton before about, and that found that pleasingly they had already thought of this, which is could we take Brown Dog services and then find the data and ship it down to where that data is at rest. That's very important for this thing we're doing with the BRAIN initiative, because those BRAIN scans and the models that result are very, very large. So we want to push things like subsetting and so forth down to where the data is at rest. And I'd be really interested.
Yeah, you can also do it in such a way that an app can be replicated, and you can have replicas, and you can easily then say, okay, there's already a replica there where the data is located. I don't need to even ship it.
Yeah, and so I'd want to ask Kenton, is there a way to expose something so that he could put buttons on, let's say, NDS share, but in terms of finding where that data is at rest, is there a way for a site to say, here's the sandbox, here's how when you ask an app to be run, I could pick that up and use the same sort of infrastructure to push that down to one of these compute resources, for example. That would be really, really interesting. Like if we could be a provider, if you will, of that kind of functionality, what that would entail.
Actually, if you're storing, I think you are doing it. I'm just being a devil's advocate here. If you store an app as a data set in IRODS, you automatically inherit all those facilities which IRODS provides with you, with access control and replication and versioning and all those nitty-gritty things, which authentication, authorization, everything.
Yeah, we're interested in that for as a preservation task. Because the DE will already do, like if you run an analysis, I'm maybe out of time, but if I'm looking at an analysis that has run, the idea is it is repeatable. It's keeping data about that, what happened, what app was run. I can see the parameters, I can tune them and relaunch it to achieve repeatability, which is a big thing everybody's looking for. So the idea of being able to at a point preserve what's happened and keep the computational Docker image with the data is at least a step towards having a complete preserved image of whatever the task was.
Mm-hmm. Okay.
Any last questions?